Okay, everyone. Hey, welcome to my first attempt of distance learning. So, basically, this is the first time ever, so please give me feedback, hopefully constructive, on ways I can improve what I'm doing here. Basically, I'm going to go through a PowerPoint, and as I go through the PowerPoint, we are going to attempt to at least for these next couple weeks until maybe I get different feedback, we're going to use this Google Classroom as a platform where you got the instructions to come into here. And then you're going to watch my videos. And then from the videos, you should be able to complete the assignments that I give you. So we'll give it a shot. We'll see how this works out. And hopefully everybody, I haven't even mentioned anything. Hopefully everybody has had a safe break. I know we had an extended break, which was kind of boring because of the social distancing. It really is kind of a bummer that this is the way we have to leave. Hopefully not end the class year, but it really does look like this is the way, this is a reality. I'm hoping I could get back in and teach at least one or two classrooms in front of real people. But it's that is looking like it's less and less of a possibility. So I'm going to do the best I can. In my opinion, this isn't really what teaching has been for me in the last 31 years, but what the heck. I'm learning a new skill, and hopefully it is helpful, and I'll try to make these as brief and to the point as possible. I'm assuming you're probably going to be taking notes in your journal, your physics journal. If not, obviously you'll have access to these videos that I'm making, so you can always pull them up. So watch the videos, get what you can out of them, do the assignments. Will we have tests? I'm not sure what that would look like in this type of a situation. Maybe if we get back, there might be a final exam. I don't know. We'll just do the assignments. I will record them in Infinite Campus, and turn them in on the dates that I put in Google Classroom, and we'll go from there. All right. So let's jump right into it. Today we're going to talk about reflection. Those of you that were here the last day of school before our break, before this whole COVID-19 disruption occurred. We talked about shadows. We talked about how you use rays, straight edges, to make ray diagrams to explain light phenomena. So today we're going to actually look at the phenomena of how do images form behind a mirror. So right there, you've probably read through this. There's going to be some terminology popping your way, things like virtual image, angle of reflection, law of reflection. That's basically the topic of this lesson. So moving on. There we go. If you are keeping notes, today's date is probably like the 8th of April. Reflected light is the topic, and whatever page you're on. If you're not keeping this in your journal, there's no way I'm going to be able to check it, but this for those of you that are organized and like to keep your notes in a certain fashion. So let's move on. Reflected light. I'm going to ask you in a second to pause this video and go into your bathroom or anywhere that you have a flat mirror, and how can you make more of your body fit in the mirror? Okay, so like I just want you to test this and see if you could actually make this happen. If you wanted to get more of yourself in the mirror, what would you do? Pause the video, go do it, and then come back, and I'll tell you what I did the first time I tried this. Okay, so hopefully you went out and tried to see if you could get more of your body in a mirror. There's no way I can interact with you folks, but this is something I always ask my students. I pass out little mirrors in front of the class, and I see how do you get more of your face in there. And if, for those of you that figured it out, there really is no way. Most people think that if you walk backwards, you'll get more of your body in there. But if you keep a completely flat plane and walk forward or backward, for example, your head, it doesn't get bigger, it doesn't get smaller, it stays the same size with plane mirrors. So you were not able to get more of your body in there unless you changed the angle of the mirror. Okay, but if you kept that mirror flat and upright, you couldn't get any more of your body into that mirror. So what you saw in that mirror was a virtual image. If you take a look at this picture here, you have a candle burning, and that image inside the mirror is a virtual image. I remember as a kid thinking to myself, how does that image get in there? So I even remember we had a mirror in the entry into our house, and I would always lift up that mirror and look behind it when I was a kid to see how did that image get back there. Maybe some of you guys had the same experience. But today we're going to explore that mystery of how this image here gets in that mirror. So let's go ahead and take a look at a plane mirror. Here's a plane mirror. My little mouse, there it is. There's a plane mirror, and then here's a man looking into a plane mirror. And you can see, as you've seen every morning, then you get up and you look in the mirror, your image is inverted. Your right hand becomes your left hand in the image, right? The image right there is what we call the virtual image. So that image behind the mirror is the virtual image of that man, and he is the object. So let's look at some terminology. If you're taking notes, I'm going to zip through these quickly. You can pause if you need. But plane mirrors and reflection. So these are some of the terms. First one is normal. The normal is a line that we always draw perpendicular to the mirror's surface. In a second, you're going to be drawing this in your journal. So, if you're writing down these definitions, you can, but sometimes it's just easier to draw them out and label them on an image. And I'll show you that here in a second. So normal is the first important word of the day. Incident ray is the ray that comes in. Here's something that this incident ray, sorry, I just got a message on my phone. Hopefully that doesn't pop up for you guys. The incident ray is the ray that comes in and hits the mirror. Okay, so the incident ray is basically the ray of light that strikes the mirror. The next beam is the angle of incidence, and that angle of incidence is the angle that ray makes between the normal and that ray. Okay, so you'll see a picture of that in a second. The next one is reflected ray, which, as you probably figured out, is the ray that reflects off the mirror, and that is also measured relative to the normal. And the angle of reflection is measured relative to the normal, and that's the angle formed between the reflected ray and the normal. So again, you're going to see these. I'll draw these out for you in a second. Law of reflection, that's kind of the biggie today. Law of reflection basically says the angle of incidence equals the angle of reflection. Okay, so that's the key to understanding how this law right here will tell us how image is formed. And you'll find out here as we move on. Okay, last word is virtual image, and as I explained earlier, that's the image which appears behind the mirror. And one thing you're going to notice in all of the mirror images we look at, because we're going to look at curved mirrors on our next lesson, anytime you have a virtual image, it will always be upright. Okay, you're going to see that there's something called real images with curved mirrors, where you actually get the image to be inverted or upside down. Okay, so let's take a look at that picture so these words make more sense to you. First thing you're going to do is in the middle of your journal, just draw a flat line. I made it blue here, but you could just use your pencil, and that is going to represent a mirror. So we're going to have a reflective side of our mirror. There it is. This would be like the reflected side, and we're going to put an object in front of that mirror. And for this case, before I put the object there, let's draw this first perpendicular line, which is the normal, all right? And so this normal, my little pointer comes up there, there it is. This, you can see it's perpendicular to that mirror. So there's our normal, okay? And next thing we're going to draw on here, we'll label that normal, is this first beam coming in. This is an incident beam. So if there was an object out here emitting light, light was bouncing off of it and then hitting the mirror, this beam would be a beam of light that came in, and we draw it as an arrow. I always put a little point on it, and you notice how it is relative to this normal. So let's say that this angle between the normal and this beam is 60 degrees. So I is the symbol we use for angle of for the incident beam, and I is actually the angle, the symbol for the angle. Okay, and in this case it's 60 degrees. So that's the angle of incidence, 60 degrees. Now, once this beam hits, there it is, it's going to bounce off of the mirror, reflect off of the mirror. Oh, there, yeah, right there you can see that's the angle of incidence. It's going to bounce off of the mirror at the exact same angle relative to the normal. So that would also be 60 degrees. So that's our angle of reflection. I'm going to draw a little squiggly line there. It's kind of funky looking, but that, so you can see the angle of incidence is also equal to the angle of reflection. Incidence equals angle of reflection. So that probably helps explain some of that terminology that I gave you earlier. Now let's put this all together to see how this makes a virtual image. Oh, one last thing. See this 30 degrees here, because this that normal is 90 degrees to the mirror. That 30 degrees is relative to the mirror. You won't be using that when you use calculations in a mirror equation, which I'll be showing you later on. Not today, but in a different lesson. Okay, so I'm going to show you a little video clip I made that helps this whole law of reflection make sense. In order to better demonstrate the law of reflection, I've set up a laser mounted on a physics book, and here I have a mirror on a turntable. What I'm going to do is, as you guys can see, the incident beam is going in right at 90 degrees, bouncing straight off and coming back towards the laser. You'll notice as I spin the turntable, the incident angle is obvious right here, and then the reflected beam is right here. If you use this line as a frame of reference, you could see that the angle of incidence equals the angle of reflection. I'll spin it more. You can see as I increase the incident angle, the reflected angle also increases. All the way to almost 180 degrees, and then back. The law of reflection. Okay, so after looking at that video clip, hopefully it helped you understand the law of reflection. Now we're going to actually do some drawings where you can see the how this virtual image of an object appears to show up behind a mirror. Okay, so let's jump right into it. You don't have to draw this one. I'll have you draw a candle later on, but right now I'm just going to walk you through a first example. So watch how this works. Let's suppose this L I drew is the object, and you guys can see the mirror right here is in front of the object, and we are going to eventually form a mirror image of that L over here on the other side, and it should be the exact same distance behind the mirror as it is in front of the mirror. So the way we do that is we start off with drawing some incident rays. So this first incident ray I drew, I didn't even draw a normal on that mirror because this is going to come in straight at the mirror, and once it hits that mirror at 90 degrees, it's going to bounce off, just like that. So hits 90, reflects at 90, reflects at 90, and that's our first two rays we're going to draw. You don't have to draw this, just watch as I go. I'm going to go ahead and do put a normal on this mirror, and notice how I put the normal on both sides. The normal goes on the front of the mirror and behind the mirror. I'm going to go ahead and draw, coming off of this angle, this top of the L, I'm going to draw an incident beam. Notice right there, that's my angle of incidence right there. And then I'm going to draw a reflected beam that comes off at about the exact same angle, just like that. Okay? Now I'm going to go ahead and draw another normal. This time I'm going to come off the bottom of my L, right here, and I'm going to shoot an incident beam down there with my straight edge. And right here, I can't find my cursor, there it is. Right here is going to be my angle of incidence, and then I'm going to have another beam shoot off like that. And that's going to be my angle of reflection. And that would be my angle of reflection right there relative to the normal. Okay? So you're asking yourself, okay, what does this do? I don't see a virtual image, right? Well, if I'm standing over here behind the mirror, come on cursor, where are you? And I'm looking down into this mirror, and let's say my eye is up here, this beam comes into my eye. What my eye appears to see is this beam going into there. So this beam shoots into here, and so what we see is a virtual beam of light coming off of these. I'd see it coming, if my eye was right here, I'd see this beam here going into the mirror right there. So I'm going to go ahead and draw, let's start with this first one. I'm going to use blue, oh no, green, I'm sorry, green. That's kind of crooked, but this beam right here represents this beam that I see from out here. So I have a green light, this reflected beam going in. I'm going to do the same thing with this one. This reflected beam appears to be going inward into the mirror, and if my eye's over here, this reflected beam appears to be going in there. So you see those beams, I drew them a certain length just so you guys could see the image that forms. Right here I could draw a whole bunch of beams, and where they cross is where this image will appear to form. And I'm just going to take the shortcut, and that would be it. So as you guys could see, these lines line up with the reflected beams that came off of them, and that's how our image appears. Well, this virtual image that we see, it will always be upright. Virtual images are always upright. In a case of a plane mirror, it's going to be the same height as the object, and it will always be the same distance away from the mirror as the object is. So like if this object was 1 meter away, this image would be 1 meter for a plane mirror. Okay? All right, your turn to try. So go ahead. I'm not going to have you turn this into me, but I do want you to practice. Try to practice it. I'm going to step you through it. We're going to make an image of a candle. So here's our candle, and there's our plane mirror. You'll need a straight edge for this. You'll need a pencil that you can draw the candle and the virtual image and your rays with. Okay? If you don't have a ruler, you can even use like the edge of like a box, something that is just nice and flat. If you have a protractor, that would be great. If not, just kind of improvise. Find something at your house you could draw on a sheet of lined notebook paper. Okay? All right, so this is what you're going to draw. Right in the middle of your paper, draw a flat line, which represents your mirror. To the left of that, go ahead and draw a rectangle. If you have different colored pencils, that'd even be better, right? In this case, I'm going to draw an orange rectangle for the base of the candle, and then I'm going to put a little triangle on top of it. So there is my candle. Okay, nice, really basic candle. It's a certain distance from the mirror. You don't have to worry about that distances. And, you know, this is your first ray diagram of a plane mirror. Let's see how it comes out. All right. From there, if you follow along, I'll show you what your steps are. We're going to go ahead and draw 3 different normals. I just throw those on your mirror anywhere you want. Try to make them perpendicular to the mirror. So like if you have a protractor, it'll be really easy to do that if you don't have a protractor, but try to line them up so that they're nice and straight coming off the mirror, perpendicular. And we're going to draw a series of lines here. These are going to be our incident rays. The first incident ray we're going to draw is off the base of the candle, straight on, and then it's going to bounce straight off. Okay? Again, I'm going to do these. You can pause the video and keep going as I go. I'm going to come up here to about right there. I'm going to draw one. Oh, sorry. Before I do that one, let's go ahead and draw it. Now, this next line you draw, if you have a different colored pencil, make it a different color so it looks different than your incident beam. And just shoot it straight back there. That is and go as far back as you want. Put a little point on it. Don't worry about how long you got to make it, but make it long enough so it goes almost to the back of your paper. Okay? Then we'll go up here and we're going to draw another one. So there's my incident beam. Then I do a black reflected beam, and then let's put that virtual beam in there, nice and straight. So 2 real easy lines you've drawn right off the bat. Let's go to the top of that candle and draw another incident beam, draw a reflected beam, and then coming off that reflected beam right here at the base, just shoot another one straight back behind the paper, like so. Okay, so there we have 3 virtual beams behind our mirror. They're not crossing with anything, no indication of an image there. Okay, so now these other ones come into play. Whoop, I just tapped it. So coming off the base there, I had that beam come in. So now we have this angle of incidence right here. I'm going to try to mimic that here. If you have a protractor, it's easier. And I shot it straight out there. And then we're going to shoot this one in behind there. Nice long line. And that is our virtual beam. Ooh, look at that, where they crossed. So that's going to have some significance. That point right there is actually going to be that base of our candle. So we got a first crossing point. That'll make it easy to draw in a second. Okay, let's go ahead and use this other normal. I'm going to come off the top here of the candle. I got my angle of incidence. I have my angle of reflection right there. And I'm going to project this reflected beam behind the mirror. And then as you can see, we have a point right here where they crossed. And I have one more up here, one more normal. Let's come off the tip of the candle, the top of the candle. Angle of incidence right there. Try to make our angle of reflection the same. This one shoots out this way, and then we're going to project it through here where it crosses. And there you have it. Look at these 3 points where it crosses. Those all correspond with here, the top point here goes there, the base here corresponds right here, and here to here. So I'm just going to have my image come in there. There's our mirror image of the base, and then the mirror image of the flame. And that, folks, is how we make virtual images using ray diagrams. Okay, so hopefully you had fun with that. Hopefully it was easy to figure out. That's the lesson for today. If you have your book, hopefully you all have it. If not, I'm going to go ahead and make a copy of the assignment. I'll scan the book page and put it in Google Classroom. Here we have your assignment due this week. Physics to Go. If you read Physics Talk, page 541, 543, it's basically everything I covered in this lesson. Physics to Go, page 546, numbers 2, 3, 5, 7, 9, and 10. Basically, you could read it, or if you understood this video, you probably can answer all those questions without even reading it. Honors, why don't you guys, there's a kind of a fun challenge where on page 544, Active Physics Plus, you're going to draw the image, 3 images of an object standing outside of 2 mirrors that are perpendicular to each other. Okay, so you'll read that one, see how you do. Good luck with it. I'll show you how to do it on my next presentation. That's how I'll open up the next class. Hey folks, hopefully this went well. I know it's 22 minutes. That's a long time to sit in front of the computer, but that's your lesson. Okay, I'll talk to you. I'll see you. Well, you'll see me. I probably won't see you in the next video. Thank you.